Download this code from codegive.com, link in the description below. A deep dive into business logic flaws for bug bounty, focus, $1,000 bounty scenario. This tutorial will explore business logic flaws, specifically focusing on scenarios that could realistically earn you a $1,000 bounty. We'll cover the fundamentals, common types of flaws, methods for finding them, and provide a proof of concept, POC, with code examples, where applicable. Keep in mind that bounty amounts depend on the specific program, severity of the impact, and quality of your report. A well-documented POC demonstrating significant impact significantly increases your chances of a higher reward. Understanding business logic flaws. Business logic flaws are vulnerabilities that arise from errors or oversights in the intended functionality and behavior of an application. They allow attackers to manipulate the system to achieve unintended and potentially harmful outcomes, often by exploiting the application's own rules and workflows. Key characteristics **** not a traditional vulnerability ***, unlike XSS, SQL injection, or CSRF, business logic flaws often bypass traditional security controls, like firewalls and web application firewalls. They exploit the application's intended functionality in unexpected ways. Context dependent ***, the severity and impact of a business logic flaw depend heavily on the specific context of the application and its purpose. What might be a minor inconvenience in one application could be a devastating vulnerability in another, example an e-commerce platform. Require deep understanding Finding business logic flaws requires a solid understanding of the application's functionality, data flow, and intended user interactions. Black box testing can uncover some, but often a white box or gray box approach is more effective. Difficult to automate Automated scanners typically struggle to identify business logic flaws because they require human reasoning and the ability to understand the application's purpose. Manual testing and creative thinking are essential. 2. Common types of business logic flaws, with example scenarios. Here's a breakdown of common categories, each with a realistic scenario that could potentially qualify for a $1,000 bounty, depending on impact and program scope. 1. Discount abuse Description exploiting vulnerabilities in discount code logic to apply discounts inappropriately, stack discounts, or generate unauthorized discounts. Scenario, high impact an e-commerce platform allows customers to apply multiple discount codes. An attacker discovers that by combining a student discount code with a promotional code for new customers, they can reduce the total price to zero or even negative. This leads to free products or refunds, potentially costing the company significant revenue. POC, code example, simplified Python. Explanation The calculate _price function iterates through the discount codes and applies them sequentially. The flaw lies in not preventing the application of both discount codes simultaneously, resulting in an excessive discount. The invalid _code gives a price of $0. The max function is used to make sure the price is not less than 0, preventing a refund being issued to the user. Report impact significant revenue loss for the e-commerce platform. Mitigation implement validation to prevent stacking of certain discount types. Add rate limiting to discount attempts. Review discount logic thoroughly. 2. Insecure workflows and state management Description circumventing intended workflow steps or manipulating application state to bypass restrictions or gain unauthorized access. Scenario, high impact a platform for managing patient medical records requires a two-factor authentication, 2FA, Setup after account creation. An attacker discovers they can directly access sensitive patient data by crafting a specific URL that bypasses the 2FA setup workflow. They effectively skip the step where 2FA is enforced. *POC, conceptual. 1. Create a new user account. 2. Instead of proceeding through the 2FA setup flow, intercept the URL for accessing patient records, example/patient/12345/records. 3. Modify the URL to include a bypass parameter, example/patient/12345/records, skip_2FA equals true. This is a hypothetical example, the actual parameter would depend on the application. Or change the cookie value. 4. Submit the crafted URL. 5. If successful, the application displays patient records without requiring 2FA verification. *Report impact * unauthorized access to sensitive medical records, potentially violating HIPAA regulations and causing significant reputational damage. Mitigation * enforce 2FA setup before granting access to sensitive resources. Validate user state and authentication status on every request. Remove bypass parameters. 3. Insufficient input validation and data type handling ***. Description ** exploiting vulnerabilities caused by inadequate input validation or mishandling of data types, leading to unexpected behavior and potential security breaches. Scenario, medium to high impact. A financial application allows users to transfer funds between accounts. The application uses a hidden form field, or a cookie, to store the transfer amount. An attacker discovers they can modify this field to a negative value. When the transfer is processed, the attacker's account is credited with the negative amount, effectively stealing money from the other account. *POC, code example, conceptual PHP. Explanation ** The vulnerability lies in the insufficient input validation. While there's a check for 0 which would not catch a negative number, it would also not catch an invalid data type being passed to the amount parameter such as -1. By sending a negative amount, the attacker makes their balance grow and the target's balance lower. Report impact * financial loss for users and the platform. Mitigation * thoroughly validate all input, including hidden fields and cookies. Use appropriate data types, example integers or decimals, and enforce limits. Sanitize all inputs before using them in database queries. Add an additional layer of validation for the transferred amount to disallow any number equal to, or below 0. 4. Race conditions ***. Description ** exploiting vulnerabilities that arise when multiple threads or processes access and modify shared resources concurrently, leading to unpredictable and potentially harmful outcomes. Scenario, high impact. An online ticketing system allows users to purchase limited edition tickets. An attacker uses automated scripts to simultaneously send multiple purchase requests for the same ticket. Due to a race condition in the ticket allocation logic, the attacker is able to successfully purchase more tickets than the system intends to allow per user. This results in the attacker hoarding tickets and potentially reselling them at a higher price. *POC, conceptual. 1. Identify the API endpoint or form submission used for purchasing tickets. 2. Develop a script, example using Python with the requests library or a similar tool, to send multiple purchase requests concurrently. Use threading or asynchronous requests to maximize concurrency. 3. Run the script with a high number of concurrent requests. 4. Monitor the results to see if more tickets are purchased than the system's intended limit. Report impact * unfair access to limited edition tickets, potential profit for the attacker, and customer dissatisfaction. Asterisk mitigation asterisk implement proper locking mechanisms or transactional control to ensure that only one process can access and modify the ticket inventory at a time. Use optimistic locking to detect and resolve conflicts. 5. Insufficient rate limiting and abuse of resources asterisk asterisk. Asterisk description asterisk exploiting vulnerabilities caused by inadequate rate limiting or lack of restrictions on resource usage, allowing attackers to overwhelm the system or abuse its functionality. Asterisk scenario, medium impact. A website offers a forgot password feature. There's no rate limiting on password reset requests. An attacker can repeatedly request password resets for a target user's account, flooding their email inbox with password reset links and potentially causing them to miss legitimate emails. This can also be used as a denial of service attack against the email system. Asterisk POC, code example, simplified Python. Explanation asterisk the script repeatedly sends password reset requests to the specified email address. Without rate limiting, the website will likely process all the requests, flooding the user's inbox. Asterisk report impact asterisk denial of service against the email system, annoyance and potential disruption for the target user. Asterisk mitigation asterisk implement rate limiting on sensitive endpoints, such as password reset, account creation, and login. Use CAPTCHAs or similar mechanisms to prevent automated abuse. 6. Price manipulation/exploitation. Asterisk description asterisk exploiting flaws in how prices are calculated, stored, or applied in an application, allowing an attacker to purchase items at a significantly reduced or incorrect price. Asterisk scenario, high impact. An online marketplace calculates shipping costs based on the declared weight of the item. There is no verification of the declared weight. An attacker declares a drastically lower weight for expensive items, significantly reducing the shipping costs, and essentially gets cheaper shipping than intended. Asterisk POC, conceptual. 1. Add an expensive item to the shopping cart. 2. During the checkout process, or via the API if available, intercept the request that sends the item details, including the weight, to the server. 3. Modify the weight value to a very low number, example 0.01 kilograms. 4. Submit the modified request. 5. Observe the significantly reduced shipping cost. Asterisk report impact asterisk revenue loss for the marketplace due to undercharged shipping fees. Asterisk mitigation asterisk implement weight verification using external APIs, example connecting to a database of standard weights for items or using a third-party shipping service API that provides weight estimations. Set reasonable limits on weight declarations. 7. Referral program abuse. Asterisk description asterisk exploiting vulnerabilities in referral program logic to gain unauthorized rewards, credits, or other benefits. Asterisk scenario, medium to high impact. A ride-sharing app offers referral credits to both the referrer and the new user they refer. An attacker creates multiple fake accounts using disposable email addresses and generates referral links for their main account. This allows them to accumulate a large amount of referral credit which can be used for free rides, effectively costing the company money. Asterisk POC, conceptual. 1. Create a main account on the ride-sharing app. 2. Use disposable email services, example Mailinator or automated email account creation scripts to create multiple fake accounts. 3. Generate referral links for the main account and use these links to sign up for the fake accounts. 4. Verify that the referral credits are applied to the main account. Asterisk report impact asterisk financial loss for the company due to unauthorized credits. Asterisk mitigation asterisk implement strong referral verification measures, such as requiring new users to provide a valid phone number or credit card, or introducing a waiting period before referral credits can be used. Detect and block patterns associated with fake account creation. 8. Coupon farming. Description automating the process of collecting and applying coupons/promo codes through multiple accounts to gain an advantage or discount. Scenario, medium impact. An online retailer sends unique coupon codes to users via email upon signing up. An attacker scripts the automation of account creation using bots and disposable email addresses. The attacker collects all the unique coupon codes that are sent to these accounts, and then applies all of the unique codes to their main account when purchasing a product. This leads to significant profit for the attacker, at the loss of the company. POC, code example, Python, conceptual. Explanation *. This will automatically create new accounts. Because many signups don't validate, the use of randomly created domains, and randomly generated emails can work to generate codes that are later applied to a single user. Report impact * could be detrimental to a company's success. Mitigation * validate emails thoroughly, and check the email for an existing account. Do not provide coupon codes to randomly generated emails. 3. Techniques for finding business logic flaws. 1. Understand the application's functionality *. This is the most critical step. Read documentation, explore the user interface, and understand the intended workflows. Focus on high-value features, example payments, user management, data access. 2. Map data flow *. Trace how data enters the application, where it's stored, and how it's processed. Identify potential vulnerabilities in data validation, storage, and retrieval. Use Burp Suite, or similar tools, to intercept and analyze requests and responses. 3. Identify assumptions and constraints *. What assumptions are the developers making about user behavior? What constraints are in place, example limits on purchase quantities, access permissions. Try to violate those assumptions and constraints. 4. Focus on edge cases *. Test unusual inputs, unexpected sequences of actions, and error handling. Try to trigger unexpected behavior or error messages that might reveal underlying vulnerabilities. 5. Consider the business context *. What are the critical assets and processes that need to be protected? What are the potential consequences of a successful attack? Use this information to prioritize your testing efforts. 6. Use fuzzing *. While not as effective as targeted manual testing, fuzzing can sometimes uncover unexpected behavior that might indicate a business logic flaw. Fuzz inputs that are not strictly validated, example discount codes, user-defined values. 4. Crafting a high-quality bug bounty report. A well-written bug bounty report significantly increases your chances of getting a higher reward. Here's what to include. 1. Clear and concise description *. Clearly describe the vulnerability, its impact, and the steps required to reproduce it. 2. Detailed POC *. Provide a step-by-step proof of concept, POC, that demonstrates the vulnerability. Include screenshots, videos, and code examples, if applicable. Make it easy for the security team to understand and verify the issue. 3. Impact assessment *. Clearly explain the potential impact of the vulnerability. How could an attacker exploit it? What are the consequences for the application and its users? Quantify the impact whenever possible, example potential revenue loss, data breach, service disruption. 4. Remediation recommendations * Suggest possible solutions to fix the vulnerability. Provide specific recommendations based on your understanding of the application and its architecture. 5. Clean and well-formatted report. Use clear and concise language, proper grammar, and formatting. Organize the report logically and make it easy to read. 6. Avoid speculation. Stick to the facts and avoid making assumptions or unsubstantiated claims. Focus on what you can demonstrate with your POC. 7. Respect the scope. Ensure that your testing and reporting are within the scope of the bug bounty program. Avoid testing against systems or features that are explicitly excluded. Important considerations for a $1,000 bounty. Impact is key. To justify a $1,000 bounty, you need to demonstrate a significant impact. This could include significant financial loss for the company. Unauthorized access to sensitive data, example PII, financial information, medical records. Disruption of critical business processes. Reputational damage. Uniqueness and novelty. The vulnerability should be original and not a duplicate of a previously reported issue. A novel exploitation technique or a unique combination of vulnerabilities can also increase the value of your report. Quality of the report. A well-written, comprehensive report with a clear POC and a strong impact assessment is essential for a higher bounty. Program scope. Make sure the vulnerability is within the scope of the bug bounty program. Some programs exclude specific types of vulnerabilities or specific features of the application. 6. Ethical considerations. Always obtain permission before testing. Only test on systems that you have explicit authorization to test. Respect the privacy of users. Do not attempt to access or disclose user data without authorization. Do not exploit vulnerabilities for personal gain. Report vulnerabilities responsibly and give the company a reasonable amount of time to fix the issue before disclosing it publicly. Follow the bug bounty program's rules and guidelines. 7. Conclusion. Finding business logic flaws can be challenging, but it can also be very rewarding. By understanding the principles outlined in this tutorial, you can improve your chances of identifying and reporting high-impact vulnerabilities that could earn you a significant bounty. Remember to focus on understanding the application, mapping data flow, identifying assumptions, and crafting a clear and compelling bug bounty report. Good luck and happy hunting!